No laughing after the class started. Start. Ah, yeah. Okay, guys. So we are online. So Asit, Ayash, and Yohasa joining online. Yohasa, hi. So people, so we are going to start the measurement part today, and going to do some practical stuff. We have the instruments here. So I'm going to share a bit of the instruments with you, and you just have a hand-on feeling about it. That's enough. And if you want to measure something, that's even fine. You know, the practicals won't be coming for the SFT, but for ET it's there. So no worries. Now share this. Take one, like take one each. Hear you loud and clear. Nice. Thank you for that.
So those are the vernicals.
Yeah, those are the vernicals. So give me one. Just I have to show it. Shall I take one? Please take another one. So guys, this is the the actual one. We had the simulation. It was like one of a bigger one. So this is the actual size because we only measure. That's the Allen key. One for each is, I think, will be enough, huh? Wouldn't it be enough? Like how many micrometers are there? Like you share it. Somehow you just share it, depending on the. Right. So this is the actual one. So this is small, right? It's small in size, and it can only measure up to, like, check the main scale length, like how many divisions can it measure, or how many millimeters can it measure the maximum. So of this one, it goes maximum up to 25 millimeters. This only goes maximum up to 25 millimeters. So that's a really small amount, right? 25 millimeters is like 2.5 centimeters. So why is it really small? What do you measure with it?
I can't rotate.
You can't rotate it? No, don't break it. No, okay. And now it's rotating, right? Yeah, sometimes you have to grease it. That's some oxidations may be there. Right, so like check the maximum scale, like don't break it, don't take the like the thimble එක එළියටම ගන්න එපා. Right, එතකොට මේකේ maximum 25 millimeters, which is like 2.5 centimeters, and it's a really small size. Like the maximum is even really small. So why is it like really small? Anyone guess the answer? Why is it like really small? Why does it only measure like really small values? Because its least count is 0.01 millimeter. That's 1/100th of the millimeter. So for a lower least count, it doesn't like for a very lower least count, it doesn't have to go for the larger values to measure, right? So if it is a very low least count, the very low least counts are used to measure the lower lengths or the lower values. That is when the accuracy comes. So if the lengths are larger, there's no point going into very small least counts, right? Because the larger the length, the accuracy is more, right? So the instrument with very lower least counts are made to measure like small lengths, right? Because when you are measuring the really small lengths, you will get a like low accurate values if you didn't measure it using a like lower least count. නේ lower least count එකක් තියෙන එකකින් නෙමෙයි නම් ඔයා මැන්නේ ගොඩාක් පොඩි length එකක්. ඒ පොඩි length එක accuracy එක අඩු වෙන්න පුළුවන් ඒ හින්දා. ඒ හින්දා පොඩි length මයින්කොට අනිවාර්යෙන් ඔයා measure කරන්න ඕන මොකකින්ද? Yes. Hey, what's this? 0 එකක් තියෙනවා. ඒ අර Allen key එකකින් මේ nut එක තද කරා නම් හරි. මේ තියෙන nut එක තියෙන Allen key එක දාලා තද කරා. මේක කරලා තද කරා. ඇලන් කී එක තියෙන මේක තද කරන්න තමයි.
සර්කියුලර් ස්කේල් එක.
ඔව් circular scale එක නේ නට් එකකින් තමයි තද කරන්න ඕන. Right, anyhow, so you have it, you feel it, try to measure something, like put something in the here චුට්ටක් තදලා අදින්න ඔක ඔක්සිඩයිස් වෙලා ඇත්ත ටික. එන්නේ මේ කඩන්න එපා. Right, so guys, like me have some sympathy because I couldn't sleep last night, like I had to work over the night, had to make some papers for the 2025 people, so I'm like bit of dizzy and I might go out of my mind, then so me පිස්සු වැඩ කරන්න එපා. කෙලිම පිස්සු ඇදලාගේ පයින්න පුළුවන් එකපාරටම ඇයි වෙන්නේ මේ පොඩ්ඩක් අමාරුවෙන් ඉන්නේ. පොඩ්ඩක් ට්‍රැක් අවුට් වගේ වැඩ යන්න පුළුවන්. Right, so shall we come to the
So how do you spell?
huh
How do you use this one?
that is just to you know the to like me ඔය නට් එක තද කරන්න තමයි තියෙන ඇලන් කී එක. ඒක දාලා තද කරන්න ඕනේ. Right, listen, හරි ඕක ළඟ තියාගෙන හිමීට මොන හරි මෙෂර් කරගන්න. Now come to the lesson, right? So the zero error, right? Listen, so there are two zero errors we already discussed. What are the two zero errors? One is positive zero error and the other one is negative zero error, right? So measuring the zero error of a a linear instrument is, it's easy because you just only have to check the zero and you have to check the measure if it has gone passing the zero value or has it started before the zero value, right? But in the circular scale, like in this instrument, how do you find if it is a negative zero error or a positive zero error? Like now, just looking at the diagram, can you tell me if this is a positive zero error or a negative zero error?
Positive.
You're telling positive. Why is that?
Because it passed the zero. Right.
It passes the zero, like the zero has both ways. So now the zero passes upwards and zero can be passed downwards as well. So what makes the error a positive zero error? Because we always measure the values upward, right? In the micrometer screw gauge, we are always measuring the values upwards. Right? මේ බලන්න values වැඩි වෙන්නේ 0, 5, 10 likewise upward තමයි values වැඩි වෙන්නේ. So upward values measure කරනකොට when you are measuring the upward values, if the like මෙන්න මේක තමයි midline එක. හරි? මේ midline එකෙන් තමයි අපි value එක measure කරන්නේ. If the midline passes the zero for like upwards, if the midline passes the zero upwards, that's a positive zero error, right? And if the midline passes the zero downwards, that's a negative zero error, right? So those are the two errors that can happen. So if the midline passes the zero upwards, that's a positive zero error. If the midline passes the zero downwards, that's a negative zero error, right? So that's how it usually happens. So like in this one, this should be a positive zero error, right? Because the midline has passed the zero upwards toward the positive values, right? Or the upward values, right? So this is a positive zero error. Now how do you gonna measure it? Like how do you calculate the value of the zero error here? How do you gonna do that? Someone? Anyone? No? How do you gonna measure it? Now I'm asking like how do you take the reading or how do you measure the error? You just measure it
When
same like taking a usual measurement, right? දැන් මේකේ බලන්න ඔයාට 0 error එක විදියට තියෙන්නේ කීයක් මෙයා ඉස්සරහට ගිහිල්ලාද? It has gone up to 2 divisions නේ. divisions දෙකක් උඩට ගිහිල්ලා. ඒතර ආ 0 error එක විදියට measure කරන්න තියෙන්නේ මේ divisions දෙකනේ. So that 2 divisions, if we take it as a value, how much is it? 0.0 2, right? So the positive zero error should be 0.02, right? So how do you measure it? Same way you are measuring or taking a simple reading, right? සාමාන්‍යයෙන් reading එකක් ගන්න විදිහට තමයි ඔයාගේ මේකේ measurement එක ගන්න. ඒතර positive zero error එක ඔයාට normal measurement එකක් ගන්න විදිහට මේක ගන්න පුළුවන්. right? No issues. right. අපි යමු topic එකට උඩට. right. Come to zero error. When the anvil and spindle touch each other, the zero of the linear and circular scale should be overlapped, right? හරි නම් main scale 0 එකයි circular scale 0 එකයි මොනවා වෙලා තියෙනවද? overlap වෙලා තියෙනවනේ spindle එකයි anvil එකයි touch වෙලා තියෙනකොට නේ. right. So if not, zero error occurs, right? First, let's consider of an instance where the zero of the linear and circular scales overlap before anvil and spindle touch, right? So now the two of the zeros have overlapped or has aligned before the anvil and spindle touch each other. So there's a gap when the zeros are aligned, right? So there's a gap when the zeros are aligned. So that means if there's a gap when the zeros are aligned, that means is it a positive or a negative? If there's a gap before, like if there's a gap when the two of the zeros are aligned, that means when you're taking the measurements, would you like that gap, would the gap be added to the measurement you are taking, or would it be deducting? You supposed to deduct it, but does the value add to the measurement, the real measurement, or does the gap deduct the real measurement? It is adding, right? I'm not talking about the correction එක ගැන මේ අහන්නේ. ඔයා measurement එක ගන්නකොට අර gap එක මොනවා වෙනවද? add වෙනවනේ. ඒ කියන්නේ that is a positive zero error, right? So if there's a gap and two of the main scale and the circular scale zeros have aligned already, that means it's a positive zero error, right? Right. So in these instances, the reading should be taken as usual. Now highlight this one. එතකොට මේ තියෙන positive zero එක ඔයාගේ zeros දෙක align වෙලා තියෙන්නේ. align වෙලා තියෙන වෙලාවේදී gap එකක් තියෙනවා anvil එකයි spindle එකයි අතර. Can someone show it? තියෙනවද එහෙම zero එකක් තියෙන එක? තියෙනවා නම් බලලා පෙන්නන්න. එතකොට negative. Oh. දැන් ඔක tight වෙලානේ තියෙන්නේ. tight වෙලා තියෙද්දි 0 to 0 align වෙලා තියෙන්න ඕන හරියට. ඔව්. ඒ ඔක tight වෙලා නැද්ද? නෑ ටයිඩ් වෙලා තියෙද්දි ගන්නකො ටයිඩ් වෙලා තියෙද්දි මොකද වෙලා තියෙන්නේ 0 to 0 align වෙලාද නැද්ද නෙගටිව් එක පිටිපස්සට ගිහිල්ලා තියෙන්නේ ගොඩක් කාට නෙගටිව් ඒවා තමයි ඉන්නේ yes yeah there's a zero error yes
So it's
has it gone back or forward
gone downward.
then it's a negative zero negative
If it's negative, then if it's negative, the correct value should be added.
yes
Positive
yes
should be
to the
added.
final value yes right so make a highlight කරන්න yes මෙන්න මේක highlight කරන්න in this instance the reading should be taken as usual right එතකොට මේකේ positive zero error එකක් නම් ඔයාට error එක normal reading එකක් ගන්න විදිහටම තමයි ගන්න තියෙන්නේ හරිද no difference එතකොට ඔයාට positive zero එකක් આવුතින් normal reading එකක් ගන්න විදිහටම ඒ තියෙන error එක අපි read කරගන්න right so මට එහෙනම් මේක කියන්න what is the zero error there here in the diagram what is the zero error here I'm asking the value 0 point how much is the least count 0.01 so that into 2, that is 0.02, right. So, the positive 0 error here is 0.02, right. Right. The 0 error shown in the figure is how much? Write it this way. So, it should be least count into 0.01 millimeter into how many divisions has it aligned? 2. So, 0.01 millimeter into 2 is the 0 error, right. 0.01 millimeter into 2, right. Every time a reading is taken, 0 error should be subtracted, highlight it. So, the 0 error should be subtracted because it is a positive 0 error, right. So, these things are easy, right. Come to the next one. Next, let us think of an instance where the anvil and spindle touch each other. The 0 of the circle has surpassed the 0 of the linear scale, right. Now, the spindle and anvil has touched each other and the 0 has surpassed, right, or the midline has surpassed the 0 value, right. An instant like this one. Can you see it? Now, the instance this happens, the spindle and anvil has touched each other, right, they are in contact. Now, these two lines should be aligned, but now what has happened? It has gone down, right, it has surpassed the 0. So, what kind of a 0 error this now? It is a negative 0 error. We call it negative because we see it has gone down, right, has gone down passing the circular scale 0 value. So, it is a negative 0 error. Now, how are you going to measure it, the value? How are you going to measure it? Can you just take the number of divisions and multiply it by the least count? Would it be correct? No, right? If you just take the number of divisions and you multiply it by the least count, that would be something 0.46 or something. Now, is it the real 0 error? No, because it has only come back how many divisions? 1, 2, 3, 4. So, how are you going to take the error calculated now? You have to use a different formula. What is the formula that you are going to use, like the practical one? What have you, like, what do you have to do? When you are taking the least count, when you are taking the 0 error, you have to like deduct the number of divisions from the total number of divisions, right? Why would you adapt? Like now the number of divisions has aligned is 46 now, right? The number of divisions has aligned is 46. So, the actual divisions has come back is 4 divisions. So, how do you get 4 value? You deduct the 46 by 50. That is the way you get the 4, right? So, when you are taking when you are taking the 0 error here, what you do is you deduct the number of divisions that has aligned by the complete number of divisions in the circular scale, right. So, you have to deduct the number of divisions has aligned by the complete number of the circular scale divisions and multiply it by the least count. That way you get the negative 0 error, right. Right. So, shall we, right.
So, say that number of divisions deducted by the total number.
Yes, number of divisions aligned should be deducted by the total number of divisions in the circular scale. Shall we write it? Oh, yeah. In this, to get the negative 0 error, to get the negative 0 error, you have to deduct the number of divisions. That has aligned. You have to deduct the number of divisions that has aligned from the complete number of divisions in the circular scale. Right? Get it? Right. Nice. Okay. So then come to the next part. As shown in the figure, the zero of the linear scale overlaps with the which division? Overlaps with the which division? Key division එකක්ද overlap වෙලා තියෙන්නේ? කීයත් එක 46 ලියන්න 46 overlaps with the 46th division 46th division of the circular scale. Therefore, zero error is how much? How do you write it? 50 minus 40 into 0.01. Shall we write the least count first? So 0.01 times 50 minus 46, right? 0.01 times 50 minus 46. Get it? Right. And the zero error should be, what should you do to get the correct answer? To do the correction? If it is a negative zero error, it should be added, right? It should be added. So the zero error should be added from the reading taken by the instrument. It should be to the reading taken by the instrument, right? Right. So applications of the screw principle. Now in some instruments, the micrometer screw gauge or the linear circular scale is used, right? In some instrument, like what? Like in cameras. Have you seen like when you rotate the, what do you call that part?
Lens.
Do you call it lens? The rotating part? Now there's a part that you rotate in the, yeah, like in that one, right? So when you rotate it, the lens comes out, right? So there's a circular motion and a linear motion. So that's the screw principle as well. And in some, you know, some machineries, and even in, like, I have one microscope that it has the stage has like 2 clips, that the clip gets attached to the slide that you like at the specimen on, right? So there's a slide, glass slide, and it's attached to one of the, like 2 of the strips. So there's a screw. When you rotate it, the slide will move like forward and backward. Even if you want to like move it left and right, you can move it with the screw. So now the screw is rotating like in the circular motion, and the strips are moving forward and backward or left or right in a linear motion. So that is also screw principle, right? Like the sieving machine. Does it move? Yeah, right? Sieving machine. Needle goes up and down. Yes. Yes. Yeah, even the sieving machine. Yeah. Yeah, even the telescope. Telescope, sieving machines, like sort of so many machines are there, like where the screw principle is used, right? So listen. So lathe with parts that move small displacements, camera lens can be shown as applications of the principle. In case such a moving, the tool post in machines, like there are tool posts in machines, or podi tool post එකක් මෙහෙම ඉස්සරහට පල්ලෙහාට යන machines තියෙනවා. හරිද? ඒකෙත් ඔය screw principle එකම තමයි තියෙන්නේ. Like the lathe machines moving in the platform of the operating machine back and forth and left and right, moving the camera lens back and forth are done according to the measurements in instance such as that the screw principle is used, right? So ඒ වගේ සාමාන්‍ය screw principle එක පාවිච්චි වෙනවා, right? Okay, so that's so far about the micrometer screw gauge, right? So we took the measurements, right? And there will be questions coming in the future, right? So there will be a paper. So like by this month, most probably we'll be able to finish the area volume part and the measurement part as well. So after finishing 2 of the lessons, there's one other tube, the trigonometry, and I hope before starting trigonometry we'll have a paper. Would be good, right? And area volume as well. Like I'm hoping to give both. Yeah.
So when it is scheduled?
Before the month ends.
July.
Yeah, like the month end එකේ වගේ අපි paper එකක් තියෙනවා. හරි. Now the questions will be a bit tricky. Will be a bit harder than the actual L paper because like yeah. Because like it's a good thing to brainstorm and like do more than the level of that you're going to face, right? Yeah. ඒක පොඩ්ඩක් අමාරු කරලා දෙනවා ඊට වඩා චුට්ටක් අමාරු කරලා ගොඩක් අමාරු කරන්නේ චුට්ටක් අමාරු කරලා දෙනවා. You have to use the brain, right? You have to think it. Right? Use the brain and think it. Then you will, yeah. නෑ සාමාන්‍ය ඒ type එකක් නෑ. Now that's the thing. Now ඒ වගේ lessons තියෙනවා එකට mix කරලා එන. ඒ දෙක එහෙම type එකක් නෙමෙයි. And none of the questions were there in the paper, so I'm not gonna do that because it's not useful, right? එහෙම ඕනේ. Right. Okay. Now come to this part. Measuring small masses, right? Listen. So I'm gonna do a game in this one, right? There will be a game that you have to let's see how we're gonna do it, like if it is in a group or not. So now this is about measuring the masses, like the small masses. So what is the instrument used to measure the small masses? The triple beam balance, right? The triple beam balance is used to measure the small masses. So in the triple beam balance, in the triple beam balance, what is the physics behind it? What is the method used in it? What is the method used in it? In the triple beam balance? And do you all know the triple beam balance or not? You all know, right? Triple beam balance is like it has 3 beams and a disc. So it balances and then you get the measurements of the mass that you are putting on the disc. That's what usually happens. And now triple beam balance has a method or a physics behind it. What is the method used in it? How do you get the values? What is the physics using in it? The balancing the what? Balancing the torques, right? Balancing the torques or the momentum, right? Balancing the torque or the momentum, which is length into force, right? Because if there's a stick and you have put a pivot point in the middle, something like this. Right? So if you have let's say you have a stick like this, like the seesaw පැදලා තියෙනවනේ. Now in the seesaw, what's there in the middle? There's a hinge, we call it pivot point. Pivot point means the point which the axis rotates, right? Now here this is the pivot point, right? So when this stick is under the equilibrium, or if the stick is in the balance, that means the left hand side rotation and the right hand side rotation should be equal. If the stick is under equilibrium, or if the stick is stationary, has no movement, that means the left hand side rotation should be equal to the right hand side rotation, right? So when this is like අපි හිතමු මේක balance එකේ තියෙනවා කියලා. So if I put a mass on this, what happens? It will go down, right? And this side will go up. And what happens if I put a equal mass in the edge of this side? Again it will get balanced, right? So what can we say now? So if you add the equal amount of mass, on the either edges of the stake, that they get balanced, right? So let's say you are putting an unknown mass here and you are balancing it with a known mass from here. So using that known mass you can measure the unknown mass. Get it? Right. So this is what we do. Let's say I have a balance like this. Now I am going to measure it using three types of different masses, right? So I am going to put a mass of this much, right? So I am going to put a mass of, let's say 439.4. Okay, so that's a random mass, grams of a mass. Now what happens? The stick will go down. Now this side will go down. So it will be sort of a position like this, right? It will be in a sort of a position like this. And you have these several weights, like you have 100 grams of weights there. You can take many as you want. And you have 10 grams of weights as well. And you have 1 grams of weights and 0.1 gram of weights as well. So you have 4 types of weights, right? And you are going to put any number of these weights and going to measure the weight you have added here. Now, like though I put the value here, let's assume that you don't know the value is 439.4. You don't know it, right? And you are going to measure it using these known weights, right? So you are going to put any number of the weights in the either side of the edge, like in the other side of the edge, and going to balance it. So once the stick is balanced, that means the number of weights added here should be equal to the weight of this one, right? Right. So you're going to add the weights. Now tell me which weight would you add first? 100 so, 10 so, 1 grams or 0.1 grams? Which? So many answers are coming. Now gather together, discuss and tell me one answer. Which should you add first? Like even the guys online. Tell which weight should be added first? The hundreds, tens or 1 grams or 0.1 grams? 100 grams. Hands up those who tell it's 100 grams. 10 grams. 1 gram. 0.1 gram. 0.1 gram. Right. So guys, if you added like 0.1 grams times, how many like 0.1 grams would take to get balance the weight that is added to the other side? Yeah, many will take, right? You can add it like over the night and take maybe 2-3 days. So can't do it like that, right? Can't do it like that. It won't be practical. You can do it, but won't be practical. Can't be doing it practically. So what should you do? You have to add the greater weights first. That means 100 grams, right? So now listen. So what are you going to do first? Listen. So you're going to add 100 grams first. Now I'm going to add like, let's say these are the 100 grams. I'm going to add 100 here. Now this is 100. I'm going to add 100 here. Would the stick go down? Not really. No. Like it either has to be equal or close to get the stick down. Otherwise it won't move. Never would happen. Like if you have experienced it, at least riding a seesaw. At least if it is approximately equal or greater than it, it will go down, otherwise no, right? So it has like many hundreds to go to get it equal, right? So nothing will happen. So you're adding another 100. Would it go down? No. So adding another 100, nothing happens. And you're adding another 100. What happens? Would it go down? Let's say little bit. Little bit goes down. Now you're adding another 100. Listen. What happens? Another little bit will go down. And you are going to add another 100. Now what happens? It will completely go down, right? It will completely go down. So what can you conclude using this? Like, what is your conclusion? The weight here is less than how much? 500 and more than, that's the thing, right? So the weight added here, like the weight added here should be less than 500 and more than 400. So you are going to remove 100, right? So you have to remove 100. I removed 100. So what happens now? The stake that went down will again go up, right? Right. So now you can't add any more hundreds, right? So almost all the like the maximum number of hundreds are added now. So what's next you are gonna add? The 10 grams. Bro, 10. The next greater one, right? If you added 1 grams, again it will take many times to get it equal. So the next one should be the tens, right? Next one should be tens, right? Many geniuses are there. So how many tens you are gonna add? Right? So the first 10 you are adding. What happens? How much is it now? 410. Is it enough? No. So you're gonna add another 10. How much is it now? Is it enough? No. Another 10, that is 430. Is it enough? No. Like 9 grams more there. So you can add another 10. What happens? It will go down. Now there is a decision to take now. So what is the conclusion now? The value added here is less than 440 and greater than 430, right? So what are you going to do now? You have to remove one. Like you added 440 and it went down. That means the weight here should be less than 440. And when you added the 430, it didn't go down, right? So that means it's greater than the 430, right? So it's more than 430 and less than 440. So I'm going to remove a 10 gram back now, right? So now what happens? It will again come up. So what are you going to add now? Now the 1 grams, right? So you're going to add 1 grams. Let's say you're going to add this one. Right, so you are going to add 1 grams. Now I'm going to add 1. How much is it now? 431. Now it is 430. I have to go 9. 4, 5, 6, 7, 8, 9. Nothing happens. Like it will almost come closer, but not even, right? So I'm going to add another one. What happens now? Now it will go down, right? It will go down. It will go passing the, the line which is equal to the balance, right? So what is your decision now? What is your conclusion? Now the weight here should be more than 400 more than 439, but less than 440. So you're going to have to remove 1 gram, right? You're going to have to remove 1 gram. Now what do you do? Yeah, you have to use a different one. The lowest mass. How much? 0.1 gram, right? So you're going to add a 0.1 gram of it. 0.1 gram. So that is 439.1. Now it's almost close, right? Now it's almost close. So 439.1 9.2, 9.3, and when it's 9.4, the the stick will, yes, it will be straightened back to the horizontal line, right? So now you know how much is the value. How do you calculate it? Using the weights that you added. How much of a weight did you add? How many 400s? 4. 4, right? 400. You had to go 400. And how many 10s? 3. How many 1s? And so how many 0.1 miles? 4. So altogether 439.4, that is 439.4 grams, right? So that is the way the the triple beam balance works. But instead of using the weights, it uses the torque, right? It's something like this. Let's say there's like a clip, right? So there's a small clip that you have to take it from point to point. Let's say you're adding now the clip doesn't change, right? Make a weights change or a clip change. So you're putting the clip here. Let's say you're putting this clip here in the stick, on the stick, and that gives 100 grams of a value, right? And you move it here, like along the stick, you take it upwards, so to the further, like the further end. What happens? Now if this is 100, the next point will be 200, because when the distance gets increased, the torque will be more, the torque will be higher. That means the force that is given is also higher. So instead of using the mass, they are using the torque, right? When the distance increases, the torque increases, so the force that is given will be increased, that can be get equal to the mass. So if you put it here, it will be 100, and if you put it here, it will be 200. If you put it further, the weights will be increasing. So you don't have to use many of the weights. Instead, you can use the torque. Just use one clip and increase the distance. You will give a greater weight, right? So that is the method which is used, right? So this instrument is there. So we are going to use a simulation for that, and we are going to calculate some of the values. And I'll be wanting few of your people to come to the board. Not you. You came last week. And where's the VGA cable here? Oh. Now, right, now listen, right, so no shouting. Apo drum gathering, මෙතනට ගිහලා dance කරන drum beat එකට. හරි. Listen. Now this is one of the triple beam balance at prototype, right? So the actual one looks the same, but like has more actual look, like making an color. Yes, it has like a bit of a 3D. I will show it as well. So now, as I said, like we use one stick, right? One beam. Now this has 3 beams. That is why it is called triple beam. And as I said, like there are clips that you have to move forward and the mass will be increasing. Now there's a disk here, that is where you put the unknown mass. And when you put the unknown mass here, now there's a pivot point here, because when you put the mass here, it will go down and the arrow here will go up, right? And when you put a like mass here, the arrow will go up, so you have to take it back to the equilateral point, right? So to take it back to the equilateral point, what you have to do is you have to move the masses, like move the clips to give a equal torque or equal mass to this side, which is equal to the object that we put in the disk, right? So like there are 3 beams and the beam values are different, like the weights that we use. So the weights that we use were like hundreds, then the tens and 1 and 0.1, right? So the same way, the likewise, now the middle beam, right? The middle beam has like 100 values. Do you see it? 0, 100. So if you take the clip here, it will give a 100 gram of a value to this side. And if you move the clip to 200, it will give 200 grams of a value this side, right? And likewise 100, 200, 300, 400 and 500 is the maximum hundreds that it can go, in hundreds, right? That is the maximum it can go. And there's another beam, the upper beam, which is calibrated in 10 values, like 10 grams, 20 grams, 30 grams, 40 grams, 50 grams, 60 grams, 70 grams, 80 grams, 90 grams, 100 grams, right? And the lower beam, which is in the 1 gram values, so 1 gram, 2 gram, 3 gram, 4 gram, 5 gram, 6 gram and maximum up to 10 grams. And do you see like 1 gram has divided into how many divisions? Now how many divisions are there? 10 divisions. So that 1 division will be equal to 0.1 gram, right? So there are like 3 beams and it can measure like 0.1 values, 1 gram values, then the 10 gram values and 100 gram values. Get it? Right. So what we do is we are going to put a mass here, right? And when you put the mass here, the arrow will go up and you have to move the clips for the certain like the mass values, and until it get balanced you have to move all the the clips, and once it is balanced, the values which are aligned in the clips will give the complete mass which is there in the disk, right? So we are going to do that. So how do you going to do that, right? So it's a game. So somebody has to come to the board, right? Not you two, someone else has to come. Yes, Sandru, come now for today. Come to the board. Now everybody is going to help him. Come, everybody have to help him, right? So we're gonna play the game. Play game Mubanna. All right. So now do you see the arrow has gone up? Now this has a timer. It will exceed. Now which part should you move first? The hundreds, right? So move the hundreds first. It doesn't move that way. Use the mouse එක use කර. Mouse එකෙන් යන්න. මම හිතන්නේ මේකෙන් යන්නේ. ඔව්. mouse එකෙන් උස්සලා දා. අන්න ඒක උස්සලා දා. මේ පල්ලෙහෙන් පුළුවන්. පල්ලෙහෙන් පුළුවන්. middle beam එකනේ. plus 200. මේකෙන් check කරන්න. 300 වැඩි exceed වුණා. 200. ඊට පස්සේ others help. තව එකක් යන්න ඕනනේ. No, it's too much. Hari, that is the maximum hundreds. That is 300. Now ඊට පස්සේ කීයද? The upper beam නේ 10 වලින් යන එක. Now that is the bottom one. $60, $70. Now is it equal? Now check with the decimal values, the bottom B I think you lost. The timer went up, right? So timer's up. I'll take another. Let's take another one.
So the weight is unknown.
Weight is unknown. So you have to find the weight. That's the game. Yeah. It's not finished yet. Now he didn't find any of the. Right. So this is what you do. Right. Listen. So when you like start, there will be a value like added to this. Right. So the arrow here will go up. So you have to balance all the beams to get the value there. So first you have to balance the middle beam, which is the hundreds, then the top beam, and finally the bottom beam, and you have to calculate the value when you have to answer it here in these values. මෙන්න මේ ටිකෙන් මෙතන දානවා. දීලා submit කරන්න ඕන before the time ends. You see like මේ 40 seconds තමයි තියෙන්නේ. 35 seconds is the maximum. Yeah. But still it depends on the sensitivity as well. We get put a sensitivity madi. Huh? Anyway, we'll try it. Come. Come. So play the game. Start. Now help me. Click it. Alright. Put the values hundreds first. Check it. 500. තව එකක් කියවන්න බැයිද? බෑ නේ. Okay. Tens then. මෙතන බලන්න. ඊට පස්සේ දැන් අනිත් එක කියවන්න. Right, what is the value? කීයද බා? 590 put it. 400 sorry, 500. How do you erase it? I had to erase it. It's so. Bro lost. I'll do it again. Right? Yes. Until he wins. Right. Start it back. Help it. Bros, help it. Right. So 500 is there. 40. That's too much. I use this one. How was it too much or like did it go 2 times back? Peripura gaya ne? Peripura pitipasata giyada koyද? You should add another 10, I think. No, I think you should add another 10. It went too much back. Time up. Time up, bro. Time up. Now who's gonna come next? Someone come, not you. Sir, come. Come. You come. Others help him. Game starts, right? Enough, right? That was too much. That's right. No, another one back. That's too much. Bro. So many 1 grams have to take back. Bro, I have to click so much. Coming. Time up. Let's take another one. You got your kamaru in Indian. Right, starting. Enough. Too much. That's enough. Too much. That's enough. Bro is good at it. The line, ne? Didn't line. Key. Where is it? 21. Submit it. Two. Oh. That's it. Somebody else want to play? Short bro, come. Kotai. Kota bro, come. Come. अभी कोटा होगा कोटा इन्हीं में नहीं हम कर अच्छा तो मैं कब Yeah, we do. Circular motion is. More or like same. Okay. I did start already. I'm sorry. Right. Play the game. Now, guys, others help him, please. Not too much. That's it. 10. Almost. No. That's enough. That's it. You lost. Right, so nobody wins here. I'm not going to try it. No. Huh? Yeah. Yeah, podi game. Right, so that's it. Now the game is over, right? So that's a bit difficult within the time. And with the sensitivity case, I think board touch and speed madi. Nothing. Right, come. You didn't try Kalaba. Ipadang, that is enough. It will be gambling. Last year laga. It will be gambling. Gambling again. When you lose, for enough time you have to have the courage to leave it. Otherwise, it will be like gambling. Right, listen. To small measure small masses, beam balance are used, right? Triple beam balance is a widely used beam balance. Now the triple beam balance, listen. Triple beam balance is based on balancing the moment balance, right? So highlight this, balancing the moment balance. So what we balance here are the moment, right? What we balance here are the moments, right? Right. The principle used is balancing the moment around the pivot that is exerted when a weight is kept on the disc. This balance by the three beams, right? So this is the original, the instrument. So what is this one? That is the disc, right? This one is the disc. And what is this? This is the pivot point, or those are called riders, right? So this is the pivot point. Right. So that is the pivot point, which the beams are rotating. And what are these? Those are the triple beams, right? Those are the triple beams. Triple beams, or just beams are enough, right? Triple beams. And this one is the pointer. It has like already given pointer. Yeah. it should be, I think VOT. It should be PIVOT, pivot. Pivot point. Right? Pivot point. Right. Now come to the theory. Triple beam balance. When all the beams are brought to zero, no weights is on the disc, indicator should be in the zero level. If not, there is a zero error. Right? By rotating the zero, adjusting the pivot point, adjusting the pivot, this error can be fixed. Right? Error එක තිබ්බොතින් අර pivot එක adjust කරලා අපිට මේක error එක හදා ගන්න පුළුවන්. ඒතර අපිට අර zero error add කරන්න හරි deduct කරන්න හරි ඒවට යන්න ඕනේ නැහැ. මේක හදන්න පුළුවන්. Can be corrected. The least count of this is the smallest reading that can be taken by the smallest beam. Smallest beam එකෙන් ගන්න පුළුවන් smallest value එක මොකද්ද? 0.1 gram, right? The least count is stated between two parallel lines in the smallest beam, which is 0.1 gram. Right. Given below are the specifications of the triple beam balance. So how much is the least count? 0.1 gram. The maximum reading of the first beam. First beam එකේ maximum reading එක කීයද? 10. The maximum reading of the second beam or the middle beam is 500. The maximum reading of the third beam is 100. That is by so this is by 1 grams, this is by 100 grams, this is by 10 grams, right? Like 10, 20 likewise, right? So the maximum weight can be weighed without extra weights is 110 because like the middle beam has 500, the upper one has 10, 20, 100 ni maximum, so 500 plus 100, 600, and the lower beam has 10, so altogether how much can be measured? 610 is the maximum that can be measured, right? So the maximum weight that can be weighed without extra weights is 610. That is also important, without extra weights, right? So with extra weight it can be measured up to 2610. That means like 2 extra kilograms has added. Like how do you measure that 2 extra kilograms? Like if you are given like 2600 and something, that is more than 610, right? So how do you gonna measure it? How do you gonna him ban? Then අපි දුම් complete mass එක 200 and something. Yeah, sorry. Yes. How? Because මෙහෙට add කරලා තියෙන mass එක greater than that. නේ? අපි දුම් 2100 was added. Can you balance it using the masses there? Can't, because it's already exceeding the complete mass that can be added to the other side. නේ? How do you do it? තනි mass එක කඩන්න බෑ. Yes. So you mean like object එක කඩන්න පුළුවන් එකද? Let's say the object can be What are you doing? What are you doing? Can't go like over the limit. It's not gonna happen. Right? Yes. Everything is funny, but if it goes over the nose, that will be the end. Right? Listen. Yeah. Usually the small masses are measured and it's not even using now. This triple beam balance isn't using in the like the actual laboratories now. It's like an ornament, like the but now the it is just, they are just for the knowledge, right? So what you actually do is when you are measuring it, you can, like, there are like extra weights, like 1 kilogram, 2 kilogram extra weights are there. So if you have to measure, let's say 2150 grams, what you do is you put the 2600 like 2100 something mass is in here, and like 2 kilograms of extra weight you are adding this side. Like, do you see these weights? These are the extra weights. Like, there are like 1 kilogram, 2 kilogram likewise. So what you do is, like, you add a 2 kilogram extra weight on the this side. You are hanging it this side. So what happens to this 2 kilograms and this 2 kilogram weight here? It will cancel out, right? So let's say the complete weight is like 2 kilogram and 150 grams. So when you put the 2 kilograms here, this 2 kilogram to the 2 kilogram in the object will cancel out. So only the left mass is 150. Now what do? You measure the 150 gram. That's all. So that is with the extra weights, right? So extra weight is like 1 kilogram, 2 kilogram weights can be added extra on the beams. So it will give a 1 kilogram or 2 kilogram of a torque to this side. So that weights will cancel out, right? So that is extra weights, right? Right. So balance, right? The balance should be balanced by placing the blocks on the balance disc and giving a balance equal and opposite to the moment caused it by means of the loads on the bars. In balance, loads should be brought to appropriate positions on the rods, starting from the large load on the rods to the smaller load. ඒක highlight කරන්න මේක පටන් ගන්න ඕන කොතනින්ද? large එකකින් ඉඳලා පටන් ගන්න ඕන. හරිද? Starting from the large load on the rods to the smaller තමයි යන්නේ. හරි. highlight it. large එකෙන් පටන් අරගෙන small එකට තමයි යන්නේ. right? The measurement is obtained by adding the values displayed by the position of each one from the largest load to the smallest load. හරි. ඒතර මේ positions ටිකේ තියෙන masses ටික තමයි අපි අන්තිමට calculate කරලා ගන්න. right? ඔව්. scale වල තියෙන අර positions ටික අන්තිමට නතර වෙනවා. right?
So basically say the triple V balance, we put the mass and that pivot goes down and we should find the exact value it shows like
balanced. අර අන්තිමට තියපු තැන් වල තියෙන values ටික තමයි add කරන්නේ. right? We'll do an example. right? So this figure shows the way how the runners while measuring a mass from a triple beam balance, right? So find the value here. Now do the calculation. How do you going to do the calculation? You have to write down the values. Like first you have to write the how many hundreds are there. Then you have to add how many tens are there. Then you have to add how many 1 grams are there. Then finally equals to this final value. Right? Yeah. Hadan ba. Do it. Kara. Guys, people online also try to put the the values. Done? How much is it? Okay. So this one is easy. Got it. Nice. 190. 90.4. Yeah. How much is it? 190.4. Let's see the value. Yeah. You take it after the class. That's fine. Right. So how many 100 grams are there? 100 gram, right? And 10, 90 grams are there. And in the last beam, it's only 0.4 grams, right? So adding all together, how much do you get? 190.4 grams, right? That is the final value, 190.4, right? Now hands up those who got the correct answer. This one is easy, right? So none of the questions have come yet. Okay. It's too easy, none of the questions have come yet, but there's a chance, you know. Yeah. Yeah. Like there will be theory related questions as well. Like listen, for the paper, you know, now the first thing I like expect from you is like you have to know the theory really well. You know, like taking the measurements is only for the, you know, the technicians. I'm not putting them down, just I'm saying is like taking the measurements is easy, it's nothing, right? Anyone can do that, even a child can do that, right? So that's not the thing that we are expecting here. Like the science for technology is like the science behind everything, right? What you're learning and what you're doing. So you'll be using the vernier caliper and micrometer, screw gauge and everything in the future, and you'll be taking the measurements, and everyone, like usually like even people who are not much educated can still use the instruments, right? But the difference should be is you have to know the theory behind it, and if something happened, like let's say any trouble came, maybe sometimes you should have the knowledge to like create a new one, like create an instrument or build up an instrument, or maybe to like do a invention, something new, right? So you have to have the knowledge. That is the knowledge that you are getting through the science for technology lessons, right? So I'm teaching the science behind it, behind everything what you're doing, right? So the instrument, like the measurement, taking the measurements will be there. That is one thing. Apart from that, questions will be there related to the theory as well, right? So those questions will be a bit of tricky, you know, like questions will be there, like you will have to think a bit. You have to storm a bit your brain and find the answers, right? Will be there. So only like 1 or 2 questions sort of that will be there. Like the majority of the questions will be easy, that you can score, same as in the A-level paper. But other questions will answer කරන්න පුළුවන් නම්, and that is what I am expecting, like that you have learned something, that you have improved your knowledge.
So that means you have unit wise section? Unit wise?
Yeah. Unit wise exams will be there. Like
these questions are easy, right? So you're gonna put these type of questions which are easy according to you.
in general.
Yeah.
Yeah.
For us it wasn't easy, so the paper.
It was uneasy.
Yeah, this wasn't like
I'm not telling like they are like easy. Like
anyways, in general,
yeah.
according to you,
Yes.
the kind of questions that are easy,
Yeah.
according to you, will be
Yes.
added to the paper.
Yes. Yeah. Those sort of like questions will be there, like ටිකක් ගොඩාක් අමාරු කරන්න බයින්ඩ, because you are still the beginners, so I won't be hard on you. Yeah. So now the thing is this, you know, it's a like a difficult life, you know, like when it comes to the exams, you will really have to like have a let's say what do you say, responsibility about the exam, so the future that is coming, because most of the people don't know it, how, like what would be the future coming after you, right? So now the thing is this, I have seen so many people, I have like passed so many years, so when I look back, and even the time I'm spending now, I'm meeting so many students like you, and you know, the only way, like for the majority of the people to get through all the stuff that they are facing in the future, like the main thing is the economy, like, so you're not facing it now because you're like හැමෝම depending on your parents, so you are not all worrying about it for now, but you'll be worrying about it in the future, and you'll be suffering if you couldn't go through the academics, because the only way of growing yourself and earning money that you need is through academics or the education. Otherwise, it will be really difficult. So like my like first thing here is to take you up to a level that you will have the enough academic knowledge to pass the exam, not only to pass but to have a greater result. So that is why I am like trying to take things like really not, I'm not saying like really strict, but yeah, not complex, but like to a level that will be effective and it will be like useful for you all, like, and you'll be having good results at the end. That is my ambition, like for the event that will be proven with the 2025 people's result when it comes out, right? And like the majority are failing and they're not worrying, so that's a different case. So මට අර වෘතල් කරන්න බෑ. I will not give like අර පොඩි ටිකන් චුට්ටි අගයන් ටිකක් ආදේශ කරලා නිකන් apply කරලා උත්තරයක් ගන්න ඒ වගේව දෙන්න බෑ, right? So if you get lower marks, that's fine. Don't worry about it, right? If you're getting lower marks for like test in the class, that is fine. So you should worry like about the final exam that you are going to face. ඒකෙදි ලකුණු අඩු වුණොත් වෙන කේස් එකක්. ඒකෙදි worry වෙන්න ඕන. හැබැයි දැන් වර්ධිනියට you just don't have to worry, because the first thing is you have to find your faults. That is your improvement. Find your faults and answer those things, right? So like mistakes හදාගන්න එකම තමයි growth එක. When you find the mistakes, what you have to do is you have to answer it. You have to find, like, go back and see what happened there and answer it. You have to clear it, then like go through, like improve it. එහෙම තමයි යන්න තියෙන්නේ. That is the growth. So don't worry about don't worry if you have like low marks for a test like this. The main thing is you have to identify what will be the faults, then what were the faults that you were like hiding inside you, that you might didn't know. දැනගෙන ඉදියෙත් නැති වෙන්න පුළුවන්. ඒතර question paper එකට answer කරාන් පස්සේ more the wrong answers, more things to learn, right? එතකොට සමහර වෙලාවට ඔක්කොම හරියන එක්කෙනෙක්ට වඩා වැඩිපුර වර්ධින එක්කෙනෙක් වැඩිපුර ඉගෙන ගන්න. Learn through the mistakes. That is the first thing. අර ඒවට බය වෙන්න එපා. සහ දුක් වෙන්න එපා. ලකුණු අඩු වෙනවට බය වෙන්න final exam එකේ. A levels වල. දැන් ලකුණු අඩු වෙනවට බය වෙන්න එපා. ලකුණු අඩු වෙනවට මොකද කරන්න ඕන? Find your mistakes. ඒක තමයි ඔයාලට හම්බ වෙන ලොකුම උදව්ව කාගෙන් හරි. ඔයාගේ mistake එකක් කවුරු හරි පෙන්නනවා නම් ඔයාට කරන ලොකුම උදව්ව තමයි. හැබැයි ඔයාට තියෙන්න ඕන මොකද්ද? gut එකක් තියෙන්න ඕන, honesty එකක් තියෙන්න ඕන, mistake එකක් පෙන්නුවාම හදාගන්න. හදාගත්තේ නැත්තම් සදාකල් අනාතයි. ඇයි මේ වැරද්දෙන් කවදාවත් එයාට බින්දින්න බෑ. ඉතින් එයා A levels නෙමෙයි කොහේ ගියත් වැඩේ නා ගන්නවා. එහෙම ගියාන් පස්සේ දිගටම ගියොත්. එහෙනම් mistakes තියෙනවා හැමෝගෙම. ඒවා හදාගෙන යන්න. හරි. පොඩ හදාගෙන යන්න. අපි මේක අර අපිට A levels වල හොඳ result එකක් ගන්න පුළුවන් මට්ටමට අපි ටික හදාගෙන යන්න. ඔයාගේ brain power එකත් වැඩි කරගෙන යන්න. ඒතර ඔයාලා කොහේ ගියත් බය වෙන්න දෙයක් නැහැ. එහෙම නැතුව එළියට ගියොත් තමයි අවුත්. some comes genetically. හැබැයි අපිට ඒවා හදාගන්න පුළුවන්. ඒ කියන්නේ අපිට ඒක improve කරගන්න පුළුවන්. brain power කියන එක improve කරන්න පුළුවන්. It won't be much. මං බලමු මේ first එකේ ඉඳන් මං එච්චරම අමාරු කරන්නේ නැතුව නැත්නම් ඔක හිත අමාරුවක් වුණොත් ඉතින් අපරාධේ. එසේ බය වෙනවනේ. බය වෙලා ඊට පස්සේ නිකන් මූ කියලා හිතලා එහෙම වෙන්න එපා. එහෙම වෙන එක හින අවුලා. එහෙම හිතන්න එපා. බලමු. හරි first page එක බලමු මං ඒක. මට ආසයි ටිකක් අර අමාරු question ටිකක් දෙන්න ඒකයි. කොර වෙන ඒවා ටිකක් චුට්ටක්. Right. Hari. So now come to the next one. So we skipped one part, this traveling microscope part, right?
So do you have traveling microscope practice?
No. Because that is like bit of expensive and there's no use of it for myself. I don't use it.
So in SSC syllabus you don't get the practical, so you
What?
practical sample in SSC syllabus?
No. Practicals ne. You only have practicals in your like mainstream subject, ET or BST. Right.
So there is there friction in
That's right.
SFT?
Friction? Yeah, under the force, friction is there. See, no, friction is friction.
Physics are over here.
Right. Hurry. Let's start the travelling microscope. Hurry. Listen. අර මේ බොරු බයක් හදාගන්න එපා හොඳේ. බොරු බයක් හදාගන්න එපා. Now I'm clarifying everything. I'm giving you the past paper classification first thing. Right? Past paper classification එකක් දෙනවා. Lesson wise classified කරලා. ඒ කියන්නේ ඔයාගේ lesson එකේ අපිට measurement කියලා. measurement එකේ දැනට ආපු past paper questions ඔක්කොම ටික classify කරලා measurement lesson එකේ යටතේ. එතකොට ඊට පස්සේ වෙනම දෙනවා question bank එකක්. That is the model questions. Right? ඊට පස්සේ provincial papers මම වෙනම translate කරගෙන යනවා දැන්. ඊට පස්සේ full papers වෙනම යනවා. ඒ ඉස්සරහට ඔයගොල්ලන්ට ගොඩක් ඒ වැඩ වෙයි. මුල් stage එකේදී ඔයාලට PPC එකයි question bank එකයි හම්බ වෙනවා. කියන්නේ model paper question set එකයි past paper classification එකයි. ඊට අමතරව lesson wise exams යනවා. හරි. දැන් ඔයාට තියෙන්නේ ওই ටික compare කරගන්න. මොකද්ද? PPC එක දුන්නාම PPC is the real case scenario, the real thing, the real question that will come to your paper, right? Which has come in the past papers, right? So, ඒ ටික කරලා බලන්න ඔයාට ඒකේ තියෙන extent එක කොච්චරද කියලා. නේ? ඒතර ඔයාට තේරෙනවා past papers වල level එක කොයි වගේද කියලා. And in the model paper questions, the question bank, there will be lower the level of the A-level paper questions, and there will be like the questions which will be harder than the A-level paper questions as well, right? So both type of questions will be there, and then the standard level of questions are also there. So like my suggestion is go through all the stages, like lower the A-level question level, in the standard level, and like harder questions than the A-level paper should like A stages to know pahu karla yana. Like if you can do more harder questions, that means those standard level questions will be easy for you. That's all, right? අන්තිමට ඔයාට අපි කරන questions වල හොඳ ලකුණු ගන්න පුළුවන් නම් A level paper එක නැති කරගන්න පුළුවන්. හරි. ඒකින්ද වැඩ කරගෙන යන්න. බය වෙන්න එපා. බය වෙලා කරන්න බෑ මේ. හරි. බය වෙලා levels කරන්න බෑ. මේ නම් මොන හරි මේ නැටුම් හරි මොන හරි කරන්න ඕන. නේ? A levels කරනකොට මේක technology subject එකනේ. ඒ ගැන පොඩ්ඩක්වත් පොඩි වෙන්න එපා. මේවා කරගන්න පුළුවන්. හරිද? ඔයගොල්ලන්ගේ brain level එක හොඳටම හොඳයි. කියන්නේ brain functioning හොඳයි. Now the trouble is you don't use it. Right? So get used to it. Get used to use it. නේ? අපි කොහොම හරි මේක use කරන්න පුළුවන් මට්ටමට අදාගන්න. Right? Now come to this one. Traveling microscope, right? So this traveling microscope is basically used when you can't approach to the object to measure the let's say the diameter or length or something, any dimension, right? When you can't like අපි object එක ගාවට යන්න බැරි නම්, there is one thing. And like sometimes like the fragile objects that you can't handle with the jaws or the anvil and spindle, like there are like capillary tubes which are like which are glass tubes, very small, very thin, like it has a diameter more or less of a hair. So those things you can't touch it with the jaws. So you use like a separate instrument which don't have to touch it, like keeping it in a little bit of a distance, you can measure it, right? අපිට distance එකක් තියාගෙන ඒක measure කරන්න පුළුවන් instrument එක, ඒ කියන්නේ instrument එකෙන් object එක touch කරන්නේ නැතුව. ඒ වගේව measure කරන්න තමයි අපි පාවිච්චි කරන්නේ මොකද්ද? traveling microscope. ඒකේ microscopic කැල්ලක් තියෙනවා. microscope කැල්ල පාවිච්චි කරන්නේ සමහරක් වෙලාවට අපි measure කරන object එක ගොඩක් පොඩි. ඒතර microscopic කැල්ලේ මොකද ගන්න? එයාව පොඩ්ඩක් ලොකු කරලා ගන්නවා. zoom in කරලා ගන්නවා. Right? So this is how we measure it. Listen. මම මේක simulation එකකුත් පෙන්නන්නම්. ඊට කලින් අපි නිකන් theoretically මේක discuss කරගමු. හරි. Right. So there's a microscopic part there, right? මෙන්න මේ වගේ microscopic part එකක් තියෙනවා. මෙතනට තමයි ඔයා keeping the eye on, right? So this is where keep your eye on, and there will be, and it's not what it looks like. So this will be the capillary tube, right? So when you are looking at the capillary tube, there will be crosshairs, right? There will be crosshairs. Crosshairs is like, how do you say? Crosshairs is like when you are watching through a the sniper gun. Sniper gun එකේ බලනකොට crosshair එකක් තියෙනවනේ. scope එකේ බලනකොට මෙහෙම crosshair එකක් මෙහෙම cross එකක් තියෙනවනේ. ඒකට කියනවා crosshair එකක්. right? එතකොට when you are looking at the eyepiece, you will be seeing a crosshair, and this capillary tube will be like enlarged වෙලා තමයි size එකෙන් පේන්නේ. So this is what you do when you see through this, right? So ඔයාට බලනකොට පේන්නේ something like this. You'll be seeing something like this. හරි. මෙන්න මේ crosshair එක තමයි ඔයාට පේන්නේ. හරිද? ඊට පස්සේ crosshair එකකින් බලනකොට ඔයාට අර capillary tube එක පොඩ්ඩක් ලොකු වෙලා පේන්නේ. Take something colored green. Not green. Purple. හරිද? මෙන්න මේ වගේ capillary tube එක ටිකක් ලොකුවට පේන්නේ. හරිද? Capillary tube එක ලොකුවට පේන්නේ. කොටසයි පේන්නේ. right? So first thing what you do is you take the crosshair point to the middle of the capillary tube. හරි. මෙන්න මේ මැදකට ගන්නවා. right? So you take the crosshair to the middle of the capillary tube. Then you have to move it up and down, right? So then මේ තියෙන crosshair එක වාට පේන විදිය. හරිද? එතකොට instrument එක තියෙන්නේ මෙන්න මෙහෙම. මේ තියෙන්නේ ඔයාගේ මේ microscopic part එක. හරිද? මේ microscopic part එක අපි හිතමු මෙහෙම තියෙන එක මම මෙහෙම කෙලින් කරලා තියෙන්නේ. හරිද? And the capillary tube is face to face it, right? එතකොට parallelly face to face, right? So මෙහෙම තියලා ඔයාට මේ microscopic part එක up and down move කරන්න පුළුවන්. හරිද? left and right move කරන්නත් පුළුවන්. එතකොට මෙයාව මෙහෙම තියෙන්නේ මෙයා up and down යන microscope එක left and right යන්නත් පුළුවන්. එයා up and down කොච්චර යනවද left and right කොච්චර යනවද කියන එක measure කරන්න වෙනම තියෙනවා scale දෙකක්, vertical scale එකයි horizontal scale එකයි කියලා. හරිද? vertical scale එකෙන් තමයි මෙයා උඩටයි පල්ලෙහාටයි කොච්චරක් යනවද කියන එක measure කරන්නේ. ඒ කියන්නේ microscope එක. හරිද? microscope එකේ crosshair එක. crosshair එක කොච්චරක් උඩට ගියාද crosshair එක කොච්චරක් පල්ලෙහාට ගියාද කියන measure කරන්න පුළුවන් මොකෙන්ද? vertical scale එකේ. හරිද? vertical scale එකේ තියෙනවා main scale එකකුයි. ඒ කියන්නේ millimeter centimeter main scale එකකුයි vernier scale එකකුයි දෙකක්. හරිද? ඒකේ millimeter centimeter main scale එකක් තියෙනවා. ඊට පස්සේ vernier scale එකකුත් තියෙනවා. right? ඊට පස්සේ ආපහු ඔයාට මේක left hand right move කරලා කොච්චර distance එකක් left side එකට හරි right side එකට හරි ගියාද කියලා measure කරන්න horizontal scale එකකුත් තියෙනවා. ඒකේ තියෙන්නේ මෙන්න මෙතන මේ තියෙන horizontal scale. හරි. horizontal scale එකෙන් ඔයාට මෙන්න මේ horizontal length එක measure කරන්න පුළුවන් with the vernier scale as well. එතකොට ඔයාට ඒකේ vernier value එකම ගන්න පුළුවන්. right? ඒකෙත් vernier එකයි main එකයි දෙකම තියෙනවා. So what you do now? හරි. එතකොට මේක move වෙන්නේ මෙහෙමද? මෙන්න මේ කෑල්ල උඩට යනවා පල්ලෙහාට යනවා. right? ආපහු මෙන්න මේ complete කෑල්ල left hand side එකට and right hand side එකට move කරන්න පුළුවන්. right? දැන් බලන්න ඔයා measure කරනකොට කරන්නේ මෙන්න මෙහෙම. crosshair එක මෙතනද තියෙන්නේ. එතකොට එතන තියෙදි අපි තුන් මොකක් හරි value එකක ඉන්නේ. එතකොට මේ තියෙන්නේ vertical scale එක. And it has a vernier scale as well. හරි. මෙන්න මෙහෙම vernier scale එකක් තියෙනවා. හරි. ඊට පස්සේ ආපහු horizontal scale එකක් තියෙනවා. ඒකෙත් මේ වගේ measurements දාලා තියෙනවා. හරි. Likewise is there. And it has a vernier scale as well. මෙයාගෙත් vernier scale එකකුත් තියෙනවා. හරි. මේ තියෙන්නේ vertical scale එක, මේ තියෙන්නේ horizontal scale එක. Then what you do is දැන් මේ cross hair එක දිහා බලාගෙන ඔයා මේක move කරනවා up and down, left and right. හරි. අපි හිතමු ඔයා මෙයාව up and down move කරනවා. So up and down move කරනකොට vertical scale එකද පාවිච්චි කරන්නේ horizontal scale එකද? Up and down move කරනකොට vertical scale එක. So vertical scale එක දිගේ ඔයා මේ cross hair එක මේ center එකේ ඉඳන් අරගෙන යනවා මෙන්න මෙතන මේ circumference එකේ edge එකට. එතකොට මෙන්න මෙහෙම එන්නේ. බලන්න. හරියටම cross hair එක ගේනවා මෙයාගේ මෙන්න මේ edge එකට. හරි. එතකොට මේ cross hair එක හරියට මෙන්න මේ edge එක මොනා කරන්න ඕනද? touch කරන්න ඕන. හරි. මේ edge එක touch වෙලා තියෙන්න ඕන. හරි. cross hair එක touch වෙලා තියෙන්න ඕන edge එක. හරි. හරියටම cross hair එක touch වෙලා තියෙන්න ඕන edge එක. right. මේක touch වෙලා තියෙනවා. හරි. දැන් මෙතන තියෙද්දි අපිට අපි හිතමු අර දැන් මයික්‍රොස්කෝප් එකේ තොර උඩට මූව් වෙලානේ. මූව් වෙලා අපි හිතමු මූව් වෙච්ච එකේ මෙන්න මෙතන තමයි මයික්‍රොස්කෝප් එකේ තියෙන්නේ. මෙන්න මේ හරිය මයික්‍රොස්කෝප් එකේ තියෙන්නේ. එතන වැලියු එක මම ගන්නවා y1 කියලා. right. එතන වැලියු එක y1 කියලා ගන්න. ඊට පස්සේ මොකද කරන්නේ? මෙන්න මේ cross hair එක vertical axis එක දිගේ දැන් මෙහෙමනේ තියෙන්නේ. මෙයා උඩට ගිහිලා තමයි මේ measurement එක ගත්තේ. හරි. මෙහෙම උඩට ගියා මෙතන measurement එක ගත්තා. ආපහු පල්ලෙහාට එනවා. පල්ලෙහාට ඇවිල්ලා bottom එකට එනවා. ආපහු ওই විදිහටම cross hair එක අරගෙන. ඇවිල්ලා මෙන්න මෙතනට එනවා. හරි. ඒත් edge එකට එන්නේ. circumference එකේ edge එකට එන්නේ. එතනට ආවම පස්සේ අපි හිතමු මෙයා මෙහෙම පල්ලෙහාට ඇවිල්ලා he is staying at here. I'm taking the value there as y2. Right? y2. කියන්නේ මෙතන edge එකට ආවම පස්සේ value එක. ඒතර එයා මෙතන edge එකේ ඉඳන් මෙතන edge එකට ආවේ. Now the distance traveled here is from y1 to y2. මෙයාගේ edge එකේ ඉඳන් මෙතනට ආවේ කියලා කියන්නේ what is the distance traveled here? Is yes, right? And this is the diameter of the yes, capillary tube, right? And it can be measured using what? y2 minus y1, right? එතකොට අපි values දෙකක් ගන්නවා y1 වල value එක measure කරනවා y2 වල value එක measure කරනවා difference එකෙන් අපිට එනවා vertical diameter එක. හරිද? same way ආපහු මොකද කරන්නේ? මෙයාව ගේනවා center එකට. ගෙනල්ලා අරගෙන යනවා මෙන්න මේ x axis එකේ මේ තියෙන circumference එක ගාවට. එතන ඔයා value එක ගන්නවා x1 කියලා. හරි. අපි හිතමු මේ x1 එක තියෙන්නේ මෙන්න මේ හරිය. මේ හරිය තියෙනවා x1 එක. හරි. ඊට පස්සේ ආපහු මේක අරගෙන යනවා ආපහු horizontally අනිත් පැත්තට. මෙහෙම අරගෙන ගිහිල්ලා එනවා මෙන්න මෙතනට. එතනට ආවම පස්සේ එතන value එක අපි ගන්නවා x2. හරිද? අපි හිතමු a වෙනකොට එයා ඉන්නේ මෙන්න මේ හරිය කියලා. That value is x2. Now the horizontal diameter is මොකද්ද? x2 minus x1, right? So the horizontal diameter will be x2 minus x1. එතකොට ඔයා diameters දෙකක් ගත්තා මොනවාද? dy කියලා අපි ගමු. diameter y vertical equals y2 minus y1 and dx equals x2 minus x1, right? So now we have two diameters. So which one is the correct one? Or how do you obtain the accurate diameter when you have two? You take the average, right? A දෙක add කළා මොනවා කරනවද? You divide it by 2. So the accurate or the average diameter will be dx plus dy divided by 2. That will be the final diameter, right? ඒතර අපි capillary tube එකක සාමාන්‍යයෙන් uniform diameter එකක් නැහැ. It doesn't have a uniform diameter. So what do? You take few diameters using the traveling microscope and you add all the diameters together and divide it by the number of diameters you took. That is the average, right? So you take an average diameter at the end. So least you have to take two, one vertical and one horizontal, right? So that is how you use the traveling microscope. Get it? Right. Shall we come to the theory then? Now come to the theory. Right. So the traveling microscope are very useful for taking some measurements that cannot be measured with a caliper or a micrometer screw gauge. Highlight ka caliper hari micrometer screw gauge එකෙන් hari ගන්න බැරි ඒවා. තමයි අපි measure කරන්නේ මොකෙන්ද? Traveling microscope එකකින්. Measurements cannot be measured with a caliper or a micrometer screw gauge, such as the diameter of a hole in a capillary tube. सामान्य capillary tubes වල diameter එක තමයි අපි මේකෙන් measure කරන්නේ. හරි. Capillary tubes වල diameter වගේ ඒවා තමයි measure කරන්නේ. It can also be used to obtain measurements of physically inaccessible objects. මේ physically inaccessible objects වල measurement ගන්නත් ගන්නවා. කියන්නේ අපි මේ object එක touch කරන්න ඕනේ නැහැ නේ. touch කරන්න නැතුව measure කරන්න පුළුවන්. අයි අපි microscope එකෙන් බලන්නේ මයි. අර වගේදී අපි ජෝස් අස්සට දාන්න ඕන එහෙම තියෙනවනේ. මේකෙදි එහෙම ඕනේ නැහැ. That's the difference, right? The special feature of this is that the traveling microscope is used instead of the human eye, and the object can be magnified with it, and different values can be obtained along two vertical and horizontal direction. Values can be obtained two vertical and horizontal directions, which is the vertical scale and the horizontal scale. Yes. This instrument consists of two main scales located in the horizontal and vertical directions and two associated vernier scales. Therefore, the reading is same as the reading of the vernier caliper. හරි. දැන් මේක vernier caliper එකකින් measurement ගන්න විදියම තමයි. ඒකේ තියෙන vernier එකයි main එකම තමයි මේකෙත්. So the way of taking the measurement will be same, right? Nothing different. A labeling image of the part of the traveling microscope is given below, right? So මේක අපි label කරගන්න ඕන. Right. මෙන්න මේ parts ටික label කරගමු. මේ තියෙන්නේ මොකද්ද? microscope එක මෙතන තියෙන්නේ what? eyepiece, right? This is eyepiece or the eyepiece or eyepiece. මේක මොකද්ද? objective lens. මේක මෙතන තියෙන්නේ fine adjustment එකක්. මේකෙන් තමයි අපි මෙයාගේ තියෙන focal length එක වෙනස් කරන්නේ. නැත්නම් අර එයාට තියෙනවනේ lens අතර දුරක්. ඔව් අපි කියනවා focal length එක. ඔව් ඒකෙන් මේකෙන් තමයි focal length එක change කරන්න. අපි ටික ලියගමු. ඒතර මෙතන ඉන්නේ eye piece. ආපතේ මේකද මේක තමයි sorry ඔව් ඒක තමයි eyepiece එක මේ label කරන්න වෙන එක මෙතන තමයි eyepiece එක මේ මොකද්ද eyepiece මේක එන්නේ මේක ස්ක්‍රූ එකක් හරිද screw to change focal length මේ මොකද්ද මේක objective lens right මේක මොකද්ද නෑ මේ තියෙන්නේ main scale එක horizontal නේ horizontal main scale ඒකේ අපි මෙතන ලේබල් කරලා නැහැ මෙතන arrow එකක් දාලා ලියන්න එතන තියෙන්නේ horizontal vernier scale එක හරි මැද වගේ තියෙන්නේ horizontal vernier vernier scale ඊට පස්සේ මෙතන තියෙන්නේ vertical vernier එක තමයි එතන තියෙන්නේ හොඳේ vertical vernier scale right මෙතන තියෙන්නේ vertical main scale ඊට පස්සේ මේ තියෙන්නේ ස්ක්‍රූස් දෙකක් මෙතනත් ස්ක්‍රූ එකක් තියෙනවා මෙතනත් ස්ක්‍රූ එකක් තියෙනවා ඔය ස්ක්‍රූ දෙක මොකටද තියෙන්නේ මෙයාව up and down movement එකට පාවිච්චි කරන්නේ කවද මේ උඩ තියෙන ස්ක්‍රූ එකේ ඒක ස්ක්‍රූ එකක් කරකවන්න තියෙන්නේ මෙයාව left hand right hand side movement එක නැත්නම් horizontal movement එක හරි එතකොට ඒක ලියන්න screw for මේක මොකද්ද screw for vertical movement right screw for vertical movement මෙයා මොකටද screw for horizontal movement right tag gala label ka nice good හරිද ඔය ටික ලේබල් කරගන්න ටග් ගාලා yeah yes
that means the safety subject is 90% physics
it's 33% physics for the paper
second chemistry
the chemistry and physics have like the equal percentages in the paper got it done hurry right then come to the theory back listen the most of the traveling microscopes are made such that 49 lines of 0.5 millimeter overlaps with 50 parts of the vernier scale right then the least count is 0.01 millimeter now you have to calculate the length of a line in vernier scale or a division of vernier scale division එක value එක කොහොමද හොයන්නේ how do you find the division value of a vernier scale what is the equation to find the division value of a vernier scale what is the equation to find the division value of a vernier scale so there were equations to find the division value. So what is the equation to find the division value? Let's say like we have a vernier with 9, no, not that part. No, that's the measurement taken. So how do you take the division value of a vernier? Tell me like 9 divisions of main scale is aligning with 10 divisions of vernier scale. So what is the division value of a vernier scale now? 0.1. No, that is not the that a in oh gap a in least count. So what is the division value of a vernier? Even guys online can tell. Division value එක කීයද? 0.9. How do you take the 0.9 value? Huh? No. How did you take the 0.9 value? How did you take the 0.9 value? Exactly. You divide the main scale length by the vernier scale divisions, right? You divide the length by the division, right? So same thing you have to do it here. So you have to have the length of the main scale which is aligning with the number of vernier scale divisions. So what is the length of the main scale that is aligning with the number of vernier scale divisions? Here. So it's telling that 49 lines of 0.5 millimeter values. So what is the length here now? 49 lines of 0.5 millimeter values. 24.5, right? So I have to divide 24.5 by how many divisions? 50 divisions. That is how you get the division value of a vernier, right? So shall we write the equation and put the answer there? The length of a line in vernier scale or division in vernier scale equals what? Length of main scale division. Main scale අපි එක ලියමුනේ. Main scale length of main scale අපි කියලාමු. Length of main scale should be divided by VSV or the number of vernier scale VSD vernier scale divisions, right? Length එක divide කරනවා නම් vernier scale division එක. Number of divisions, sorry. Length of main scale should be divided by vernier scale divisions. ඒ කියන්නේ අපි කලින් ගත්තේ 9 millimeters aligning with 10 divisions of vernier, right? එතකොට 9 එක divide කරා 10 වලින්. මේකෙදි වෙනසක් තියෙනවා මොකද්ද? This have like 0.5 division values. එතකොට length එක වෙන්නේ මොකද්ද? 49 into 0.5 which is 24.5, right? Which is 24.5, right? So ඔයාට එනවා එතකොට කොච්චරද? මෙතන එන්නේ කොච්චරද? අපි මෙතනින්ම දාමු value එක. කොච්චරද දෙන්නේ? 0.5 into 49 millimeter divided by 50 divisions. So how do you simplify it? How do you simplify it? මේකේ 5 කැපුණාම 0.1 නේ. 0.1 into 49 is 4.9. Then again divided by 10, 0.49 millimeter is the division value of a vernier here, right? 0.49, right? And another thing, before the exams, if like first thing is you have to study all together. You have to group together and study, right? People who are like living close by, get together and study someone's place. Don't do anything else, just study, right? So now for real, like study. And like if you need any guidance, like a kuppy, we say it kuppy. Yes. Yeah, even A-level kuppy, campus kuppy, so many kuppy are there. So simply it's a kuppy, that means like කවුරුහරි යාට help කරනවා. Oh, right. So these listen. These senior අයියලක් කළා there. Listen, guys. So senior අයියලක් කළා there to help you. Actually, only අයියලා there. The akkala, these girls coming ahead. 25 වල අක්කලානේ. නෑ අක්කලානේ. Only the අයියලා there. So I can arrange few of the people to like may help you for like different groups. හරි. ඔයගොල්ලෝ groups වලට set වෙන්න. එතකොට මම මේ වගේ කීප දෙනෙක් allocate කරනවා ඒගොල්ලෝ visit කරලා ගියාද. Right. In one way it's good for them because teaching is a good way of studying in one way. The other way you will also be improving and you can share the knowledge like in their level. හරි. සමහර ඒවා ඒගොල්ලෝ simple විදියට කියන්නත් පුළුවන්. එතකොට මම්මචන් කියලා කියන්නත් පුළුවන්. එතකොට knowledge එක share වෙනවා. That's a good thing. And apart from that you have to discuss as well. හරි. කට්ටිය එකතු වෙලා discuss කරන එකත් කරන්න ඕන. So group වෙන්න, හරිද? group වෙන්න, group වෙලා set වෙන්න. ඊට පස්සේ මම allocate කරන්නම් අයියලා කීප දෙනෙක්ව. එතකොට ඒගොල්ලෝ ඇවිල්ලා කුප්පියක් වගේ දාලා හරි support එකක් දෙයි. ඒක continuously තියාගන්න. මොකද ඒගොල්ලෝ out වෙලා යනවා. ගියාන් පස්සේ ඒගොල්ලන්ගේ support එක ඕගොල්ලන්ට ඕන වෙනවා. ඒකෙන්ද ඒගොල්ලන්ව පොඩ්ඩක් shape එක තියාගෙන ආවම්පස පොඩ්ඩක් කන්න බොන්න දීලා නේ. මොනාරි පුද සත්කාරයක් කළා මේ වැඩ ටික හරියට කරගන්න. support එකක් ගන්න. හරිද? ඈ බොන්නේ ඔය එහෙම බොන්නේ. කො බොන උන්නේ හරිද? එහෙම බොන්නේ. එහෙම බොන නෙවෙයි. Right, listen. So the least count. Least count equals so the least count equals length of a line in main scale minus length of a line in vernier scale. Hi. It's almost 1:15 because we started later. I was like me taking the time over the time afterward, right? So least count එක කියන්නේ මොකද්ද? main scale division එකේ value එක අඩු කරන්න ඕන vernier scale එකේ division එකේ value එක නේ. එතකොට මට කියන්න මේකේ main scale division එකේ value එක කීයද? 0.5 millimeters. අපි vernier scale එකේ division එකේ value එක හොයාගත්තා කීයද? 0.49 millimeters. දැන් එන least count කීයක් එනවද? 0.01 millimeter least count එකක් එනවා. 0.01 millimeter least count එකක් එනවා. No, don't worry about those things. First you follow through these things. Oh. Hi, अब මේකේ ඉතුරු ටික next week discuss කරමු. එතකොට by next week, like now it's almost finished, right? So it's almost finished. So by next week, measurement it will be finished. So only the area volume is left to do, and I'll be giving the trigonometry tutor as well. So by next, no, this month, right? We started the month. So in the mid or end of the month, we'll be starting the trigonometry as well. So in the future, like in the near future, you have many questions be coming and may start studying. Them පටන් ගන්නවද? You start studying now, and exam එකට නම් set වෙලා පාඩම් කරන්න, right? ගේම් එකක් ගන්න.
Online join වෙන්න පුළුවන්ද?
පුළුවන්. Alright. Yeah, guys, put all the micrometer screw gauge in one bag.
online නම් ගොඩක් කරන්නේ ෆස්ට් එකදී.
Fine. Join on, that's okay.
Sir, physical
can use it. Put it. There you go. Right, homies. Adios. People online, adios. Just study will.